we are going to show how to find the volumes by integration. But first, we have a revision on finding the area by integration. First, you want to find the area under the curve with the x-axis, and then you draw rectangles, okay, rectangles, and then you draw many rectangles like this, okay, and then you find that the area of the rectangles you add up together is the area under curve approximately, and then you take limit n for n is smaller and smaller, and then you will get it very close, right? Okay, now we go back to 10. Okay, and now we have talked about area and how to find out the area. We just like this, look at the figure on the right. Yes, you rotate the curve along x-axis. Do it again, rotate the curve along x-axis, okay, and then add them up. What is the form of each one? It is a disc. It is a disc, okay. You just rotate and then you form a disc, okay, and then adding up all the discs, and then you can find out the area, okay. Now let's see what is the volume of the disc. We call it pi r square delta x, okay. We'll talk now. We are going to derive the formula for the volumes of solids of evolution, okay. First, we divide the curve y is to fx, okay, into different strip like what we are going to find the area, okay. But this time each strip is rotated. You rotate this strip along x-axis, rotate along x-axis. Of course, you may rotate along other axis, y-axis or any line, but here the first example is rotate along x-axis. Then what will you get is that you will get this strip, okay, you get this one. For example, you get this strip. What's this shape? Okay, I try to draw it here. Okay, this disc. It is a disc, okay. That's why we call it this method, okay. We are going to add up discs of different radius, okay. Another disc, okay. So for this what is the volume of this volume of a disc? Is that this is what we call the radius. The radius is pi r squared times its width, okay. Its width is dx, okay. So only one disc is this one, okay. The other you have another r, okay. This, make sure that these two r are different, okay. R1 or R2, okay. So what is r? R is sometimes here I call this r, and sometimes here I call this r. Actually it is the height, actually the radius, sorry, the radius is the height, okay. That is y, okay, y. So I call it pi y squared dx, okay. But you know that this is integrate from x equals to 0 to x equals to 9. So the area is integrate from 0 to 9 pi y squared dx. But you know that you cannot integrate because here you got different variables. So we are going to try to change to the same variable, 0 to 9 pi, this is fx, okay, because y equals to fx, okay, dx. Remember, square of this one, pi y squared dx, okay. So we got this formula, okay. Remember this formula. And now some students may say that if it is along the y-axis. Along the y-axis, this is rotate along the y-axis. Then it is still a disk. You see that it is still a disk, but this is in this form. Okay. And again, you think that the weight is r, then it is pi r squared, and the height is dy. But you know that you want to integrate. For example, here is from c to d. You want to integrate from c to d pi r squared dy. Okay, but the r actually is the x squared. Okay, but you know that again, you cannot, this is x, this is y, you have to change all the variables to y. So you got integrate 0 c to d pi gy all squared dy. Okay, this is the formula. Okay, this is the formula for y-axis, rotating on y-axis. Okay, so you better learn about x-axis first. This method is called this method. Now we go to the first example 11.10. Okay, the shade region bounded by the curve y equals to fx. Okay, I got y equals to fx. Okay, that is y equals to cube root of x. The line x-axis and the line x equals to 8. It's revolve about x-axis. Okay, x-axis. So you will have this kind of shape. Okay, the shape is this one, and then find the volume. Okay, so it is from 0 to 8, 0 to 8 pi, the height is y. Okay, the height is y squared dx. Okay, but you know, as I told you, that you cannot write y and x together, so you write 0 to 8 pi, okay, fx squared. Okay, that is y squared, is for this case is cube root of x dx. Okay, so you may skip this step, just write this one. Okay, remember to pi r square. Okay, I almost forgot the square. Okay, and then I got this one. The pi, I put it inside, outside is the same. Okay, and then you will get the answer after a few steps, which is definite integral. Okay, here I have to emphasize that it is rotate about x-axis. If it is rotate about y-axis, okay, this area, okay, is rotate bound by this one, is rotate about y. Oh, sorry, I jump to other page. Okay, sorry. If it is rotate about y-axis, do you know the shape? Okay, I think the shape is something like this. Okay, here like this. Okay, yes, something like this. The shape, I cannot draw it very well, but the shape is something like this. If it is rotate about y-axis, so make sure that it is rotate x-axis or y-axis. It is totally different. Okay, it is totally different. Now the second example. Okay, the curve x squared equals y squared plus 1 together with y equals minus 1 to 2. Okay, 2 minus 1. This time is rotate about the y-axis. Okay, y-axis. So the shape is something like this. Okay, something like this. Okay, of course you don't have to know the exact shape, you just have to find out the volume. Okay, so you cut into this. Okay, you cut into this. This is the radius. Okay, and then the height is dy. Okay, so it is pi r squared dy, or I say pi x squared dy. Okay, I want to integrate all of them from -1 to 2. I have to change all to y, x squared is y squared plus 1. Okay, I get this step. Then you can find out the answer. Okay, and then we look at another one. Okay, this time the curve is this one, y equals to 1 plus 6, bounded by x-axis, y-axis. Okay, and then that is this area. Okay, the shade one, rotate about x-axis, whatever x-axis. Okay, but 180 degrees. Okay, 180, that is rotate only half. Okay, only half. Okay, so the area should be half. Okay, this should be half of this. Right, this is it, right? Okay, half to this. Okay, half of this. Okay, so the height is r. Okay, that is y. R is y. Okay, so pi r square is pi y square multiplied by dx. Okay, so integrate pi y square. What's y square is 1 plus cosine x all square, and then dx from 0 to 2 pi, but remember to add 1 over 2 because it is rotating only 180 degrees. So I got this. I don't know whether you can find out the answer because you have to change this one. Okay, the cosine square have to change to the combined angle 1 plus cosine 2x over 2. Okay, that's why I always ask you to do better in the definite integral. And then this is the answer. This example shows how to find volumes of some known objects. Okay, for example, this right circular cone. Okay, how to derive the formula of 1 over 3 pi r squared h. Okay, I just rotate this line y equals to fx. Okay, along x-axis. Okay, and then this line is y minus 0, x minus 0, and the slope is h. Oh, sorry. The slope is r minus 0 over h minus 0. That is y equals to r over hx. Okay. And then what you're going to do is integrate from 0 to h dx. Okay, the height is y, pi y squared. Okay, so yes, exactly this one, and then you will get the answer is this one. That is proof 1 over 3 pi r squared h. And then find the volume of the sphere with radius r. We all know that it is 4 over 3 pi r squared, pi r cube. Okay, how to prove it? For example, the circle, this is x squared plus y squared equals to r squared. Okay, if you cut it here, okay, this is here. Okay, so this is dy and this is x. Okay, the y from minus r to r. So you're going to integrate from minus to r dy pi x squared. So it is minus r to r pi r squared minus y squared dy. Okay, and then you will get this answer. Okay.